In this lesson, we're going to look at how to add and subtract rational expressions. So again, it's worthwhile to take a minute to go over how we add and subtract fractions in general. So one of the key things to remember is that if we were to add fractions, we have to have a common denominator. So if I have 1/7 plus 3/7, because my denominator is the same in both, what I can do is add the numerators together. So 1 plus 3 is 4, and then I keep the denominator the same. Okay, I don't add the denominator, I add the numerators and keep the denominator the same. However, if your denominators are not the same, you have to create a common denominator. So for example, if I have 1/3 plus 4/9, okay, I'm not able to add these right away because my denominators are not the same. So this is where the whole idea of equivalent fractions and equivalent expressions come into play. So look at my denominators, 3 and 9. Can I multiply one of these numbers to get the other? And I should realize that yes, I can take 1/3, multiply it by that clever form of 1, right, 3 over 3, and turn 1/3 into 3 over 9, and then I can add it to 4 over 9, and I get 7/9. Okay? Another type that you might want to think of is when there is no like multiple like that, where let's say we have 1/5 plus 1/4. Right? I can't multiply 5 by anything to get 4, I can't multiply 4 by anything to get 5, but I can look for a lowest common multiple, or in this case a lowest common denominator. And sometimes that is the product of those two denominators. So for instance, 5 times 4 gives me 20. So I can rewrite 1/5 by multiplying it by that clever form of 1 of 4 over 4, and that gives me 4/20. I can rewrite 1/4 as an equivalent fraction by multiplying it by, again, a clever form of 1, 5 over 5, and I'm left with 5/20. Now that I have a common denominator, I can add my numerators. 4 plus 5 is 9, and I'm left with 9/20. Okay, so it's a quick little review on adding. Fraction subtraction works in the same way, where you would just subtract the numerators, but the denominators still have to be the same. Okay, so that's the same with rational expressions. So again, if you're going to add or subtract rational expressions, you need to have a common denominator. So in these examples here, right, the first two have a common denominator. So in this first one, we have 7x plus 1 over x plus 5x minus 2 over x. Okay, we can see here that the denominators are the same, so I can go ahead and add my numerators. So what I have now is the 7x plus 1 plus 5x minus 2 all over x. And then I can combine like terms here. So 7x plus 5x is 12x, and 1 plus negative 2 is negative 1. So what I have is 12x minus 1 over x. Nothing to be factored out of the numerator, so this is my final answer. Okay? If we look at b here, what we have is x over x minus 3 minus 3 over x minus 3. Once again, I have the common denominator, so I can subtract those numerators together. So what I'm left with is x minus 3 all over x minus 3. And I should realize from our lessons on simplifying rational expressions that these are the exact same numerator and denominator. So this entire factor is the same as this entire factor. It cancels, and I'm just left with 1. Okay, now with c here, you'll notice that we have a different denominator, right? So one is x minus 2, one is x plus 2. Okay, so I can't just add these together right away. So what I need to do is find a common denominator. And like what we did with those fractions that had different denominators and one wasn't a multiple of the other, is you again multiplied by this clever form of 1, the opposite denominator. So I'm going to take that 5 over x minus 2 and multiply it by the opposite denominator, which is x plus 2, right? So x plus 2 over x plus 2. Okay, I'm then going to take my second term, okay, and I'm just going to use this for space, and I'm going to take that 3 over x plus 2, and I'm going to multiply it by its clever form of 1, the opposite denominator of x minus 2 over x minus 2. Okay, simplifying those, right, that first term, I can distribute a property across here, and it becomes 5x plus 10 over, and I'll just leave that in factored form in the denominator, x plus 2 times, or x minus 2 times x plus 2, subtracting, and again I can distribute this across, so 3x minus 2, so 3x minus 6 once you distribute it, okay, and then over, leave that denominator in factored form of x plus 2 times x minus 2. Now I have a common denominator, so what I can do is now subtract these terms. Make sure you keep those in brackets, okay? So you're going to have 5x plus 10 minus 3x minus 6, right? You're subtracting both of those terms in the numerator, okay? So you just want to make sure that you've distributed that negative across the sign. So what you have then is 5x plus 10 minus 3x plus 6 all over x minus 2 times x plus 2. Okay, now combine your like terms, right? So 5x minus 3x is 2x. 10 plus 6 is 16, right? All over x minus 2 times x plus 2. And you can factor that numerator a little bit, but it's not going to help you with canceling because you're just going to get 2 times x plus 8 over x minus 2 times x plus 2. But you have a solution now, or an answer that's one single fraction, not two separate ones, right? So we're combining them into a single expression, okay? So again, when these denominators are not the same, we're kind of doing that same thing where we had to get a common denominator. So sometimes you kind of luck out, and one is just a multiple of the other. So in this case, let's look closely at the denominators here. Clearly they're not the same. 3x minus 12 is definitely not x minus 4. But if we were to factor that first denominator, we can factor out the 3, and it becomes 3 times x minus 4, right? And then we're subtracting 3 over x minus 4. We should be able to see here that 3 times x minus 4 is just 3 times x minus 4. Right, so we can multiply just this second fraction by that clever form of 1 of 3 over 3. So the first fraction can remain unchanged as 10 over 3 times x minus 4. And the second fraction can now be written as 3 times 3, which is 9, over 3 times x minus 4. Now, the denominators are the same, and I can proceed to subtract my numerators, and 10 minus 9 is simply just 1 over 3 times x minus 4. And now I have a simplified expression, okay? And again, all those things about non-permissible values, they would also stay in this case. So here, our non-permissible value would have been that x cannot equal 4. Okay? All right, and that's true for both of those denominators. Okay? All right, so sometimes what you want to be able to do is, again, as I've said before, factoring, factoring, factoring. Factoring is probably the most important part of anything in this unit. So before you go looking for, okay, well, what do I need to multiply the fractions by to get a common denominator, factor it first to see if there's an easier way to do it. So we'll start by factoring this first denominator. So x squared minus 9 is a difference of squares, so it will factor into x plus 3 times x minus 3. Okay, our second fraction there, okay, so we can again just leave the 4 in the numerator alone, and we can factor the denominator, and that's x plus 3, or x minus 3 times x minus 3. All right, so again, you're looking for what are two numbers that multiply to give you positive 9, but add to give you negative 6, and it's 2 negative 3's. So x minus 3 and x minus 3. So what you should notice now is that the x minus 3 is actually common in both. It's just that one has an x plus 3 and one has an additional x minus 3. So what we can do here is simply multiply what we need, okay? So this first one, okay, all it needs is another x minus 3. So I'm going to multiply this first fraction by x minus 3 over x minus 3. That's my clever form of 1. Okay, because then if we did that out, you'd end up getting 3x minus 9 in your numerator, and leaving your denominator in factored form, you'd have 1 factor of x plus 3 and 2 factors of x minus 3. Okay? The second fraction already has 2 factors of x minus 3. It just needs the x plus 3. So I would take that fraction, 4 times x minus 3 times x minus 3, and multiply it by that clever form of 1 of x plus 3 over x plus 3. Okay, it's just creating that equivalent fraction. Distributive property along the numerator, that gives us 4x plus 12 in my numerator, and leaving my denominator in factored form, I have 2x minus 3's as factors and an x plus 3 as a factor. So once again, we should notice that at this point, both our denominators have 2x minus 3 factors and an x plus 3 factor. They are identical. I am good now to combine my like terms in my numerator, right? So 3x plus 4x gives me 7x, negative 9 plus 12 gives me a positive 3. And in my denominator, I have x plus 3, and I have 2x minus 3's, which I can leave factored out like that, or I can simplify it by writing as x minus 3 squared, because I have 2 of them. You could attempt to try and factor this further, but the numerator doesn't factor at all. There's no common factor between 7x and 3, so again, this is my final answer. And once again, my non-permissible values, were I to have stated them, should in fact be x cannot equal 3 and x cannot equal negative 3. Okay? Okay, so again, we're just going to kind of continue to do some more examples here. We're going to determine sums or differences based on these examples, right? So in this first one, 2a over b minus a minus 1 over b, right? Starting off, stating our non-permissible values. Well, in this case, b cannot equal 0 because it would cause division by 0. And we can notice that the denominators are the same, so I can go right ahead and subtract. Again, be careful when you're doing subtraction that you distribute the negative across all of the terms. So what you have here is 2a minus both the terms. So it's sometimes helpful to leave it in brackets. Okay, so just to leave this as 2a and then minus in brackets a minus 1 all over b. By doing that, you remember to distribute the negative across, right? Which means you'll remember to do 2a minus a, and then the negative is also being distributed to the minus 1, so then it's plus 1 all over b, right? So then combining like terms, 2a minus a is a, and then plus 1 over b would be your final answer, okay? If we look at b down here, right, again, we already have a common denominator of x plus 4 in both of them, so I'm good to just already add my numerators together. So what I have is 2x plus 8 all over x plus 4. Now I'm going to attempt to simplify. So in that numerator, there's a greatest common factor of 2. So I can factor the 2, leaving me with 2 times x plus 4 all over x plus 4. And then we can notice that the x plus 4 is actually a common factor, right, because I factored the numerator first. This can factor like that, and my answer is simply just 2, right? However, I still would have had to state at the beginning, x cannot equal negative 4. It's still a non-permissible value in this case, right? They happen before we simplify, okay? Looking at C here, there's 3, but we're still doing the exact same thing, right? It's 3 with all the same denominator, so I can just do the operations as defined, right? So what I have here is x squared over x minus 2 plus 3x over x minus 2 minus 10 over x minus 2. Right, so all of that can be written as x squared plus 3x minus 10 all over a single denominator of x minus 2. And then again, attempting to simplify, just like we've been doing in previous lessons, can I factor that numerator or the denominator? So I'm looking for two numbers that multiply to give me negative 10, add to give me positive 3. They are 5 and negative 2. So the numerator factors into x plus 5 times x minus 2 all over x minus 2. The x minus 2's cancel, and I'm left with just x plus 5. Okay? And once again, my non-permissible values would have come from the beginning, such that x cannot equal 2, because it would cause division by 2 up at the beginning. Okay? It doesn't matter if when you simplify it, there's nothing left in the denominator, right, or you canceled out a term. The non-permissible values need to be stated from the beginning. All right. So again, let's look at a couple other ones, right? So these ones are a little bit more complex. So here, with A, what we have is 2x over xy plus 4 over x squared minus 3, and we can write that as 3 over 1. Non-permissible values have already been stated as x cannot equal 0 and y cannot equal 0. When you're asked to simplify, you are being asked to combine this into a single fraction and reduce as much as possible. So again, what we need here is a common denominator. So look at what you have and look at what would need to be done to each fraction to get that common denominator. So both of these terms here, they have x's. But this one has x squared, so this one would need another x, and this has a y. This one would need a y, right? And this one would need both the x squared and the y. Okay, so what I would do here, say, okay, I'm going to multiply this first fraction, right, 2x over xy. It needs another x, and then it's good, so I'm going to multiply it by x over x. This second fraction of 4 over x squared, it's got the x squared, but it needs a y, so I'll multiply it by that clever form of 1, y over y. And the 3 over 1 here, it needs both the x squared and the y, so I'm going to multiply by x squared y over x squared y. Okay, so that means here in my first fraction, multiply that across, what I have is 2x squared over x squared y. What I have in my second fraction is 4y over x squared y. What I have in my third fraction is 3x squared y over x squared y. Okay? The reason we do this is so that I can get a common denominator and now combine my like terms in the numerator. Right? So what I'm left with as my single fraction is 2x squared plus 4y minus 3x squared y all over x squared y. Okay? I can attempt to simplify this, but looking in the numerator, I don't have any common factors. 2, 4, and negative 3 don't have any factors other than 1. 2 of the terms have x squareds, but not the third. 2 of them have a y, but not the third. So this is actually as good as this one is going to get. Okay? So let's take a look at b. Okay, so b is y squared minus 20 over y squared minus 4. Plus y minus 2 over y plus 2, right? And the non-permissive values had already been stated that y cannot equal plus or minus 2. Because again, the first thing you would have done here is tried to factor. Now that first numerator, it is not going to factor. That is not a difference of squares. 20 is not a perfect square, but the denominator is. The denominator can be factored into y plus 2 and y minus 2. Okay? Okay. I'm not sure what's happening here. 1 second. Okay, and then y minus 2. Okay. And then this second fraction can just stay as it's y minus 2 over y plus 2. Okay? So again, what you should notice here is that both denominators have a y plus 2. So if I take the second fraction and just multiply it by y minus 2 over y minus 2, I will have the same denominator. So I don't need to do it for both. I just need to edit the second one, right? Because one was in fact a multiple of the other. Okay? So what we can do there is then keep our first fraction, y squared minus 20 over y plus 2 times y minus 2, and then plus y minus 2 times y minus 2 all over y plus 2 times y minus 2. We will actually expand this fraction, right? So what again we have in this one is y squared over 20 times y plus 2 times y minus 2 plus y squared minus 2y, which is minus 4y plus 4, all over the y plus 2 times y minus 2. Now we have common denominators, everything's expanded. Let's combine our like terms. So y squared plus y squared is going to be 2y squared. There's no y's in this first one, so the negative 4y will stay. Negative 20 plus positive 4 is negative 16. That's all over y plus 2 times y minus 2. Now I can attempt to factor my numerator. So I can start by factoring a 2 out of the whole thing, and I'm left with y squared minus 2y minus 8 all over y plus 2 times y minus 2. Looking for two numbers that multiply to give me negative 8, but add to give me negative 2 are negative 4 and plus 2. So this now factors into 2 times y minus 4 times y plus 2 all over y plus 2 times y minus 2, and cancel your y minus 2's, and you're left with 2 times y minus 4 all over y minus 2 as your final answer. Okay, and there are a couple other examples that are in these notes, but we're just going to leave those for now as we're having some technical difficulties, and these would be your practice problems to attempt with adding and subtracting rational expressions.